Hello. In this video, we will cover section 3.4, which is on comparing measures of center. When studying a distribution, when should you use the mean and when should you use the median? The shape of the distribution determines which measure works best. If the distribution is symmetric, then the mean and the standard deviation are typically most effective. This is because of the empirical rule, which allows us to estimate the spread of the distribution. If the distribution is skewed, then the median and interquartile range are most effective. This is because the median does a better job of measuring the center for skewed distributions. For the distribution below, should we use the mean or the median? All right, so what we want to do is we want to take a look. Does the distribution appear symmetric or does it appear skewed? So for skewed, we would have a long tail that extends off to one side. And that does appear to be the case here. We have this long tail that extends off to one side. The distribution is skewed, so the median and interquartile range are most effective. The median is at 226 seconds, and the interquartile range is 117 seconds. How do the mean and median compare when used on the same distribution? It depends on the shape of the distribution. If the distribution is symmetric, then the mean and the median are usually both near the middle of the distribution. If the distribution is skewed, then the mean is going to be off-center in the direction of the skew, while the median will still be in the middle. The way to think about this is that the tail pulls the mean in the direction of the skew. As a result, a right-skewed distribution will have the mean to the right of the median, while a left-skewed distribution will have a mean to the left of the median. All right, so let's take a look. So we expect that a right-skewed distribution should have the mean to the right of the median. Let's check. The median for the distribution below, that's the one we just did, is 226 seconds. The mean is 250 seconds, right? So the median is at 226 seconds. So that's going to be right around here. The mean is at 250 seconds. That's going to be right around here. They're really close to each other, actually. So it still worked, though. The few long songs in the tail pulled the mean to the right, right? So the idea is that the mean is the balancing point of the distribution. So you may recall that from a previous video. And so all of these observations that are off to one side, in order to balance with those, you have to move the mean over to that side. So you move the mean in the direction of the tail. All right. And so that is what's needed in order to keep the mean balanced, in order to keep the mean as the balancing point. And so since the median stays in the center, it doesn't have that limitation. The median is just the middle observation. And so because the median is the middle observation and is not pulled to one side in that way, the mean is going to be pulled in the direction of the tail. So if you have a right tail distribution, the mean is going to be to the right of the median. And if we had a left tail distribution, then the mean will be to the left of the median. What about outliers? Outliers are points that are far from the rest of the distribution. Outliers can have a significant effect on the mean. This is because the mean is the balancing point, as we just discussed. A single observation far from the rest of the distribution can significantly move the mean. The median is resistant to outliers. This is because the median is the middle of the distribution. An observation that is far from the rest of the distribution only counts for one observation when determining where the center is. When outliers are present, the median is usually a better choice for the measure of center. So let's look at some examples. Suppose we replace the tallest child, 71 inches tall, in the 8 children example from the last section with Shaquille O'Neal, who is 85 inches tall. What happens to the mean and the median? Okay, so if we take a look here, we can see we've got the 8 children, and that they're represented with a dot plot. We've got the 7 children with Shaq, and Shaq is way off to the side here, so Shaq is an outlier. Even the tallest child was a bit of an outlier, but Shaq is even more of an outlier. So what happens? All right, so the mean would shift from 56.2 inches to 57.9 inches. So here's the mean for the regular 8 children is right where that red fulcrum is. And if you go through and add Shaquille O'Neal, then it shifts over to 57.9 inches. So the mean moves as we move the outlier further and further away from the rest of the distribution. Meanwhile, the median is completely unaffected, right? So again, the way the median works is it's the center, it's the middle of the distribution. And the middle of the distribution, this just counts for one observation because you end up counting observations until you get to the middle, right? And so no matter how much of a outlier you put, you could go through and take someone even taller than Shaq, and even if you moved that outlier even further out, the median is still just going to stay there because the way the median is measured, where you end up counting your way to the middle of the observations to determine the median. Let's look at another example that's even more extreme. So the distribution below provides another example even more extreme, as I just said that. So with 5 employees at the same salary and the owner making several multiples of that salary, which makes more sense for the typical value / center of the distribution? Either the mean, the median, sorry, which is where all of the employees are, or the mean, which is shifted off to the right of those because of the owner. All right. So the idea is to think about this logically. If someone comes to you and they say, what's the typical salary for an employee that works at this fast food company? If someone asks you that, you're not going to take into account the owner. You're going to go through and you're going to use the other employees. You're going to use the median, which is at 16,000. All right. So the mean here can be influenced by a single observation like the owner in a way that doesn't really make sense. Like, so if someone says, what's the typical salary? And you say the typical salary is 30,000, and yet everyone who works there makes 16, and then the owner makes 100. That 30,000 doesn't make sense as the typical value or as the center of the employees, when it comes to the distribution, whereas the median does. All right. So let's look at the next slide. So it goes through and basically says all of that. And so, yes, it doesn't make sense to go through and use the mean when you have outliers. All right, so let's talk about modes. So when the distribution has one distinct peak, so meaning it's unimodal, the shape determines whether we use the mean or the median, which is what we just discussed. But what about more complicated distributions with multiple modes? Unfortunately, there is no simple answer. If the distribution has 2 distinct modes, then it is possible that there are 2 groups within the data set that could be split apart and studied individually. So that's one of the things you want to think about. This would be the case, for example, for human heights. If the data for men and women is combined, then there is a distinct bimodal pattern where you have 2 peaks, one for the men and one for the women. Below is another example of a bimodal distribution when it comes to marathon results. So if we just take a glance at this, we can see we've got 2 little peaks here, right? And the question for, how should we study this? Should we use the mean? Should we use the median? What should we do here? Well, before you even get into that, one of the things that you should think about is, what explains why there are the 2 peaks here? Is there 2 pieces of data, that explains why there are 2 peaks like that, where we could maybe separate those and then study them individually. Okay. And if you actually dig into the underlying data here, one of the things that you immediately discover is that what this distribution represents is it represents two marathon types, right? So it represents amateurs and Olympic athletes, and they've been lumped together. And so this first peak is the Olympic runners. That's their results in their marathon. And then the second peak is the amateurs. That's their results in their marathon. And so before you even get into should we use the mean or the median, you should think about whether we should separate the data. And the right answer here is to go through and do that separation. And if you break it apart, once you've broken it apart, you can see, oh, now we have a very nice, unimodal distribution for each. And then we can go through and, determine by the shape what method we should use to do the study. All right, so suppose you're comparing 2 distributions where one is symmetric and the other is skewed. What method should you use to compare the distributions? Should you use the mean or should you use the median? The answer is you should use the median. The reason is that the median is effective at measuring the center or the typical value in both symmetric and skewed distributions, while the mean is only effective with symmetric distributions. Also, if the distributions have the same shape, then you do want to go through and use the same method for both. So if it's symmetric, you want to use the mean for both, and if it's skewed, you want to use the median for both. So let's go ahead and take a look at those marathon results. If you take a look at these, the amateur results are very clearly skewed, right? So we've got a tail that's going off to one side. Meanwhile, the Olympic marathon runners are actually pretty close to symmetric. You've got a little bit of a little bit of a tail here, a little, kind of a smidge in the way of outliers, but it's close enough to symmetric that you could justify going through and using the mean. So we've got one case where we would use the median and the other case where we would use the mean. So which should we use? We should use the median. If you've got a mix of mean and median, you want to use the median. And that's because the median does a good job for both symmetric and skewed distributions, where the mean only does a good job for symmetric. The mean does not work well for skewed distributions, and so you should not be applying it to skewed distributions. All right, and so we can go through and take a look at the results here. If you do use the median on each, the median of the amateur group is 266.3 minutes, and the median of the Olympic group is 154.8 minutes. And you can see by visual observation that both are very reasonable estimates for a typical value or center of the distribution. They both look like they're in the center. All right, so let's look at a homework example. A survey asked people what maximum income tax rate as a percentage of income should be allowed, and whether those people were Republicans or Democrats. So we want to go through and compare the two political party results. So compare the shapes and the appropriate measures of center and spread. All right, so the type of questions we're going to be asked as we go through this, they want us to describe the shape of each histogram, and then because of the shape, what measure of center should be used, the mean or the median. And then because of the shape, what measure of spread should be used, the standard deviation or the interquartile range. And then they want at the end for us to compare this, actually compare the centers and the spreads within context. All right, so if we look at the distributions, we can see that the histogram of the Democrats, which is the one on the left, that is clearly skewed. It's skewed to the right. We've got a tail that's going off here to the right. And then the histogram for the Republicans is also skewed. It also has a tail that goes off to the right. All right, so the next question, because of the shapes, what measure of center should we use, the mean or the median? All right, so with skewed distributions, we want to go through and use the median. And then because of the shapes, what measure of spread is preferred, the standard deviation or the interquartile range? If you use the median, then you should also use the interquartile range. So those are linked, just like the mean and standard deviation are. So you shouldn't go through and do a mean and mix it with an interquartile range, or a median and mix it with the standard deviation. That doesn't work. The two you need to be consistent with the tools that you use. And then finally, it wants us to compare the centers and the spreads within context. All right, and so that comes down to the table here. So we're using the medians. All right, so the median of the Democrats is 30%. The median of the Republicans is 20%. And the median of the Democrats is higher than the median of the Republicans. And then the interquartile range is 34% for Democrats and 18% for Republicans. And so what does that mean? It means amongst the Democrats, there is a wider spread of results. The distribution has more variability. There is more variability in the results than there is for Republicans. Republicans have a narrower range of taxation preferences. Okay, that is the video. Thank you for watching, and I'll see you next time.